Alright, hello 7th grade. So today we're looking at the fundamental counting principle. Now you may notice I skipped over the rest of section 9.4. We got started on simulations the last time we were together, but rather than try to explain that online when we were having a little bit of, difficulty even getting through it in class, we'll get back to that when we get back to in-person simulations. We'll be back. I'm just going to skip over it because this is easier to explain online. So yay. So the fundamental counting principle, big words for something that actually ends up being pretty nice and easy to deal with. So what we're going to do with this is it ends up being a lot of word problems, so I went ahead and set up a few. So in case you can't see the colors on there, the pink ended up looking pretty much like the red. But we've got three different kinds of shirts. We've got either blue, green, or red. And we've got four different pairs of pants. I can draw pants. So we got brown, we got black, we got pink, and we got blue. So when we were talking about sample spaces, we were looking for all the different combinations that we could have if we have, these four things and those three things. So that was sample space. But fundamental counting principle deals with, well, what if we just want to know how many things we're going to end up with? We're not so concerned with what exactly those things are, just how many of them there are going to be. So I'm going to start by listing off all of my things. We're not going to do that with all of them. I'm just going to do that for this one to show you what's going on with the fundamental counting principle. So instead of calling them blue and green and red, I'm just going to call this one A and B and C. Now, you could call it B and G and R for blue, green, and red. The reason I'm not going to do that is over here I've got brown and black and blue, and they all start with B. So I figured it'd be easier to just go A, B, C, and I'm going to go 1, 2, 3, 4. So if I'm going to list off my sample space, I could have A and 1. I could have A and 2. I could have A and 3. I could have A and 4. And that's all the different things that I could have with A. So blue shirt could go with brown pants, black pants, pink pants, blue pants, and that's it. And green shirt, same sort of thing. So I'm going to say B and 1, B and 2, B and 3, and B and 4. So I could either have green and brown, green and black, green and pink, green and blue. Or I could have those same options but with C. So I could have C and 1, C and 2, C and 3, C and 4, C4. Boom. Okay, so that was a joke. So we've got four different things here that could go with each of our three different things here, and you notice, 4 and 3. So I've got four of these things that could go with each of these three things. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 different things that could happen. And the quicker way to get there, and what the fundamental counting principle thing is I can just take my 3 things here times my 4 things here, and that'll give me my total number of things, which is a lot quicker than going through and writing out every single one. You can just multiply. So if all we're interested in is our number of things, and we don't care about what exactly each of those things is, we just want to know how many of them there are, we can just multiply. Yay! For example, if I'm making a sandwich, and I could either have white bread, wheat bread, or I could put it in a wrap. And I could have either ham, turkey, roast beef, or chicken. And I could have lettuce, tomato, or pickles. And for right now, we're just going to say we could have one of those. In a moment, we're going to look at what happens if you could have more than one. If you could have lettuce and tomato, or lettuce and pickles, or lettuce and tomato and pickles. So right now, we're just going to say you can have one of those. You either got lettuce, you got tomato, you got pickles, pick one. So if we want to know how many different things we could have, we're going to have either white, wheat, or a wrap. That's 3 things. And we could have either ham, turkey, roast beef, or chicken. That's 4 things. And we could either have lettuce, tomato, or pickles. That's 3 things. And we could just multiply. So 3 times 4 is 12. 12 times 3 is 36. So there are 36 different combinations we could have with this bread, or this meat, or these vegetables. They're all vegetables. Well, technically tomatoes are fruit. But anyway, so 36 different combinations we could have with those things. Just multiplying, not so bad. Okay, now we're going to look at what if we got the same options, but let's say you could have more than one of these. So instead of just saying you could have lettuce or tomato or pickles, well, what if we could have lettuce and pickles? What if we could have all three? What if we don't want any of those? So a couple different ways you can deal with that. So this is 3 either way. This is 4 either way. And if we're looking at how many different possibilities we could have on that last one, I could have the same thing I've had before. I could have just lettuce. I could have just tomato. I could have just pickles. Or I could have any 2 of those. So if we're looking at our options for 2, I could either have lettuce and tomato. I could have lettuce and pickles. I could have tomato and pickles. And that's really my only options for 2. Because if I'm looking at, say, lettuce and tomatoes, it doesn't really matter whether I say lettuce and tomatoes or tomatoes and lettuce. Those are the same thing. So these are my options for 1. These are my options for 2. The other 2 things that are going on is I could either have none of them. Maybe I don't want lettuce or tomatoes or tomatoes. I don't want lettuce or tomatoes or pickles. I don't want any of them. Or the last thing that you could have going on is you could have all 3. Should have left myself some more space down here. So I've either got none, I've got 3 options for 1 thing, 3 options for 2 things, or I've got all of them. So 1, 2, 3, 4, 5, 6, 7, 8 different things that could happen. That's one way to get to that number. The other way to get to that number is if I treat those as 3 different things. So I could either have 3 things here, 4 things here, and I'm going to say I could either have lettuce or no lettuce. Lettuce or not. I've either got it or I don't. Same thing with tomatoes. I could either have tomatoes or no tomatoes. Or I could have pickles or no pickles. So I've either got lettuce or I don't. I've got tomatoes or I don't. I've got pickles or I don't. Now watch out for that's not 6 different things. That's 2 things and 2 things and 2 things. So instead of this 8, I'm going to have my 3 breads. I'm going to have my 4 meats. I've either got lettuce or not. That's 2. I've either got tomatoes or not. That's 2. And I've either got pickles or not. That's 2. But 2 times 2 times 2 is 8. So you're going to get the same thing either way here. So whether I go 3 times 4 times 8 or go 3 times 4 times 2 times 2 times 2, you're going to end up with the same thing because 2 times 2 times 2 is 8. So either way, you're going to get 3 times 4 is 12. 12 times 8 is 96. So you got 96 different things either way. Now, I don't think there are actually any on the homework where you can go through and do more than one of those, but I figured I'd throw that example out there because someone was bound to ask, well, what if you can have lettuce and tomato, or you can have lettuce and pickles? So all of the ones on the homework were just assuming that you can have one of those things. So like the shirts, you can't wear both a red shirt and a green shirt. So that's 96 things in that case. Now, we're going to go backwards. What if I've got a menu, and I've got 3 different types of bread, and 2 different types of cheese, and I've got 48 total combinations. So however many total things I could have, that's 48. So how many types of bread, cheese, meat, whatever that last number is, I'm ending up with 48 different combinations for my sandwiches. And I want to know, well, how many types of meat does that mean I have? So if I have 3 types of bread and 2 types of cheese, And I'm going to call it M for different types of meat. So however many types of different types of meat I have, I'm going to call that M. And my total combinations, that's going to give me 48. Okay, well now I'm just looking for 3 times 2 times what would give me 48. Now, if it happens to jump out at you right away, cool. If not, we're just solving for M here. 3 times 2 is 6. And if we got 6M equals 48, we're either looking for 6 times what would give me 48, or we can get rid of multiplying by 6 by dividing by 6. So those are gone. And 48 divided by 6 gives me 8 different kinds of meat. Yum. Alright. Now, the last thing that's going on is we're going to throw that probability thing back into the mix. So far we've just been looking for how many different kinds of this do I have. Now we're going to throw probability back in. And let's say I've got 5 shirts, and one of them is blue. And I have 6 pairs of pants, and one of them is blue. And if I'm choosing a shirt and a pair of pants at random, I want to know what are my chances of ending up with both of my things being blue. So I've got blue shirt and blue pants. So first thing I'm looking for is how many different combinations do I have altogether? And again, we can just multiply to find that. So I've got 5 different kinds of shirts, 6 different colors of pants. 5 times 6 is 30. And then I just want to know, out of those 30, how many of those are both my shirt and my pants going to be blue? So again, and, not or here. So we want to know how many of those are both your shirt and your pants are blue. And we've only got 1 blue shirt and 1 blue pair of pants. So we've only got 1 of those. So the only way we're going to end up with them both being blue is if we have both this one and this one. That's only going to happen one way. So I've got blue shirt and blue pants. That's only going to happen one time out of 30. And if you want to turn that into a decimal, or if you want to turn that into a percent, you can. Personally, I would just leave that. It's probably a little bit easier to understand as 1 out of 30 rather than like 3 point something percent. And 30. Yeah, so about 3.3%. I mean, if you want, you can. I would just leave it like this, personally. So either one of those would be okay. Technically, if you put 0.03 repeating, that would also be fine. Any of those 3 things. So fraction, decimal, percent, any of those are fine, unless it like specifically says you need to write this as a percent or you need to write this as a fraction. Any of those 3 things would be okay. Personally, I would just leave it as a fraction. There's nothing wrong with it in that form, so I would just leave it like that. Quick thing I wanted to mention about the homework. Now I need to find where I put it. Hang on. There it is. Quick thing to watch out for if you're looking at number 1. You might notice there's a little list here. Where you have plain or blueberry or cinnamon raisin or garlic. Even though cinnamon raisin ends up on 2 different lines there, that is one thing. So cinnamon raisin is one thing, not cinnamon and raisin. Cinnamon raisin is one kind of bread. Same sort of thing over here where you have cheese. You've either got plain or chive or sun-dried tomato. Sun-dried tomato is one thing, even though it's on 2 lines. So that's 1, 2, 3, 4 kinds of bagels, and 1, 2, 3 kinds of cream cheese, even though it ended up on 4 lines like that. So 4 of these, 3 of those, that's the only one that ended up like that, where it ended up scooting onto another line. I don't know why they just didn't make the table a little bit bigger so it would fit on 1 line. But every year somebody asks about that, so that is one thing. Sun-dried tomatoes are one thing. Cinnamon raisin is one kind of bread. You've got 4 of these, 3 of those. That's the only one that's kind of weird like that. The other thing that's going on is if you're looking at the streets on number 5, we're only worried about the ones that actually have names. So there's this little bit where these things have a little loop around here. Don't worry about those. Only the ones that actually have names are the only ones that we're actually interested in there. You don't need to go through and count all the little things going in and out of Harping. So that only the ones that have names here, 4 things here, 3 things there. That should be the only thing that's going on with that. Let me know if you have any questions. You can post questions in the comments if you want. You can email them to me. Let me know if there's anything in there that was confusing. And have fun with the homework.